Excellent, thank you. Good afternoon. Thank you for joining us via virtual floor space on Facebook and Zoom for the final class presentations from urban energy system students who took part in a 2-week intensive course led by Dr. Ursula Eicker. Congratulations, students. Thank you for making it here today. We look forward to listening to your presentations. So today's event will showcase the students' proposals for sustainable urban energy systems based on the development of real-life project Eco-Quartier Lachine-Est. We're really looking forward to seeing what you've come up with. We are running this event meeting style instead of webinar style, as the intent is for the participants to be able to see one another, connect, dialogue, interact in all of the ways that Zoom allows for video, audio, and text. Having said that, if there are audience members among us who would prefer to keep your video muted, please do so. And we do encourage you to also keep your audio muted throughout the session whilst other people are speaking. Questions can be popped in the chat or by raising your hand, and you'll be called upon to speak by the moderator. Those of you following along on Facebook, feel free to also share comments, and we'll relay them here to Dr. Eicker. So on that note, it is my great pleasure to welcome your professor, Dr. Ursula.
All right, so that was a bit of a shortcut by Anna. I don't know, that's what's happening if it's live. So thank you, Anna, for the introduction, and welcome everybody to our final presentation of 3 pretty intensive weeks of work on urban energy design. And I mean, in contrast to a sort of usual academic course where we just teach the thermodynamics and electrical engineering of energy systems, we decided to work on a real case study here in Montreal. And we are very happy to have a real estate developer in the team, Nathalie Volant, who you will get to know today, who helped us to connect to great people in real life, in the practical world, who work on a district development here in Lachine-Est on the west end of Montreal. And this is a project where the timing was just perfect. I mean, the idea was to create an eco-quartier, an eco-district, and just now the city with many stakeholders, non-for-profit organizations, companies, and many other players are in the middle of a zoning process. So that's where the decisions get taken of how the urban design will look like, what the requirements for zero carbon or high energy standards are, what kind of transportation concepts are pursued, and what will be done in relation to a smart waste management strategy. So in a way, this project for us proved to be an ideal size because it's district scale. And I think what our approach here in the Canada Excellence Research Chair on Next Generation Cities is to work really bottom up, to work on districts and develop tools and methodologies to analyze these districts and their future development, and then scale it up to a city or a county or an entire country. But we start at the bottom because I think for us it's the most feasible scale to make things happen, to create some impact on real life projects. So I think the project and us was a perfect match. We were also very happy to have the mayor of Lachine very involved and very interested in these ecological questions. So that was the perfect coincidence of having a strong political leader willing to make a change, a lot of community involvement in the group, and then a team of about 40 motivated students who wanted to apply everything they know onto a real case study. And obviously, in 3 weeks, you can't do it all, teach the basics, do workshops, and work on a real project. So we will present results. So we managed to get something done on the building efficiency, on the energy system design, on a waste management strategy, and on sustainable transportation. And all these 4 groups will present what they have done in these 3 weeks. And it won't stop after this course, we will continue to work on that district because I think it's one of the great projects happening here in Montreal with ambitious plans to decarbonize the development. And I think for us, it's a great chance to obtain real data and also understand the processes of what works in practice and not just do academic calculations. So I think what was also special about the course that the students from the CERC team, I mean, many graduate students, PhD, master students, and also some postdocs, basically helped to design this whole course. So we sat together some months ago and said, what would be the topics that are most relevant to come up with an integrated concept for a zero carbon district. And the students actually proposed topics, worked out material, did a lot of the presentations and scripts for the course, organized workshops on very diverse topics from electrical network modeling, thermal district design, using urban modeling engines to create all these 3D models that you will see in a while. So it was really a co-created course, which was quite nice for me because I didn't have to do all the work by myself. But it was still quite a challenge to keep it all together. So you will judge by yourself what the results will show you. So I think that's enough introduction for just now. I see that the mayor of Lachine just joined our call. So obviously, because she's the most important person of making it all happen, I would give the word to her to say a few words to the audience. And I would like to thank her very much for bringing us together with all these interesting players in the city, and even allowing us to have a site visit last Friday. So in COVID times, that was great for all of us to go to Lachine, see the site, and go for a swim afterwards. So perfect. Maya, the word is yours.
Thank you very much, Ursula, and thank you, Natalie. Thank you, all the students. It was really nice to see you all and to see you working on making it a greener and better world and to do it concretely. So I'm looking very much forward to see the work and to keep working with you until it becomes a reality on the site. So we can talk after, I'll ask you some questions. You can ask me questions. I don't know if we will have time, but to me, I know this is the end of your work, but it's the beginning of something new. So I look forward to hearing all of you today.
Great. So obviously you can ask all your questions. I know you're a specialist on waste management, so this group will be number 3. So I hope you can stay and see what they and the others have produced. But before we go to the students, I would like to invite Nathalie Volant, our favorite real estate developer in Montreal, who's doing great projects here in the city and who is participating in the course, and she will introduce the site to us and her views as a developer before we go to the students' presentation.
Hi everyone, can you hear me? I've unmuted myself, except
yes. Yes. We can hear you.
It's really an exciting moment to figure out that collaboration is the way to go. The fact that we have to stop looking at properties as something that should be owned, but something that should be shared. There's a lot of history in Montreal. Actually, well, some of the students reminded me that the history in Montreal is not the same history as some of the countries that some of the students come from, because it's a lot longer than ours. But we certainly value the history of Montreal. I've prepared a little small presentation, if Michael could put it on the screen so that we can move forward. It's been a really great opportunity to not only get to work a lot more with the CERC team, which has been really exciting, but also to get to know all of the community development people in Lachine-Est to find out what are the things that the citizens want and what are the things that could happen. And I think that most of us kind of always work in our own little backyard, and we don't realize how much everything affects everything else. So clearly, what's really exciting for us is this collaborative model. So for working together, we always speak at Quo Vadis, at my company that's 25 years old last year. We talk about working with stakeholders beyond shareholders. We talk about how the people that will be affected by the projects that you build should actually be at the table at the design process. So we look at being able to value engineer the beyond the possible. Like we always say, like, what can we actually do? Looking at it at a different angle than the business as usual model. You know, developers usually go in with a very clear idea of what they want to do, and then everything seems to be a little bit fluffy around the corners. Oh, I have to get it zoned, I have to talk to the community. We kind of see it very differently at Quo Vadis. We think about the fact that everybody has something really great to say, and we have a lot to learn. And I think that we should be a little bit more modest with our intelligence and being able to see how we can share working together. So at Quo Vadis, we like to prototype projects. Everything we do is a little bit different. Every project is different, and that's also important because the context of the project needs to be looked at where you're building. You shouldn't be building the same project in different areas of Montreal just because you've already paid for your architectural plans. The idea is to really look at the site and how it integrates into the community. But there's a lot of moving parts, and this project, probably more than some of the other ones that we've worked on as prototyping, has been even more challenging because there are so many people who care very deeply about this site, which is a great thing, and yet at the same time presents some challenges. But of course, as usual, I like to start with my quote, "It always seems impossible until it's done," by Nelson Mandela, because I think our team works very hard to try to figure out different things. And sometimes it just seems like the mountains are insurmountable and that the bridges on this picture are just not finished being built yet. So we kind of really look at how this class, working with developers, but also with the mayor, with urban planners, working with engineers, construction companies, Hydro-Quebec, like these are all different pieces of the puzzle. Michael, if you wouldn't mind going to the next slide. So for us, we always start by talking about real estate development ideology. The traditional version is always looking at the location, the scale, what it's zoned for, what is the highest and best use, usually high-end residential, by the way. What are the heights and densities, and what are the types of financial blends that we can actually put together to make this thing be financed or invested in? Then, the project comes about, and it kind of goes back and forth between the design process, the consultants that are on the project, what you can zone, what you can't. Public hearings often get involved only later on in life. So unfortunately, some of the projects are already like canned for the real estate developer. So it's a little bit difficult to move things around because really the boss of real estate traditional development is return on investment. And developers have a specific number in their brain that has to be able to move forward, whether it's for financing or investment purposes. And everything kind of goes around that. So we're kind of looking at real estate all of a sudden as a short-term investment, but we do have long-term consequences. If you can go to the next slide. So we talk about the negative side effects of development. So when you have short-term strategies that are the least exposure for the developer themselves, what happens when the developer has finished developing and leaves, and now all of a sudden these buildings are meant to be taken over by the end users that are not necessarily adapted to what they need, as an example. So you look at, construction waste, liability of the builders, you look at negative equity for the owners, you look at silo buildings, gentrification issues, kind of like a real problem, and then it kind of forces the government to come in and create more legislation to make sure that that is protected for the community. If you want to keep going, Michael. So the organizational system of real regular development is kind of like a top-down, like what Ursula was talking about. And you have all these different teams, like you have the development team, the zoning team, finance team, construction, marketing, sales. They all work all by themselves and nobody talks to each other. And we've spoken quite at length in this class, even by other people who are not me, who are saying it's much better to work together to be able to create the impact that we wish. And when we're looking at the environment and neighborhood and city strategy plans, they're kind of out in a bubble. They're not really actually looked at with any of these teams. Michael? So at Quo Vadis, we developed something called yield development. So we're looking at this project or any of our projects as an enterprise ecosystem. And what we're doing is kind of flipping it. We're looking at long-term thinking. We're looking at stakeholders beyond shareholders. We're looking at life cycle modeling, cradle to grave materials, like, you know, what happens when you demolish a building? What do you do with it? And how do you build this new building? And what are the materials that you choose for this new building? And we're really looking at the market to be able to drive sustainability issues. Like, how do you make money doing good for the community? So we create the project and the purpose directly at the very beginning of the process and go kind of back and forth before we even go for zoning. We look at what the community wants. So in the end, we end up having a flexible, modular approach to real estate development with often a lower carbon footprint. And we have livable, walkable cities that invest in relationships beyond just profit. And so we kind of like to play with words. So instead of return on investment, we decided to talk about return on human investment. When you get the humans involved from the very beginning and you look at it beyond profit, you actually do make more money doing good things because you have the opportunity to build what people want. You don't need a huge marketing budget after that. And you have less carrying costs because people buy what you want. Michael? So let's talk about Lachine-Est. What an amazing adventure it's been so far. So what's really great is that Lachine is actually very, very close to the city of Montreal downtown core. So it has a great location. It has an extremely large amount of engaged nonprofit organizations and local citizen groups that really, really care about their city, which is actually one of the best examples of civic engagement that I've seen in most cities that I've worked in so far in Montreal. But what's also really cool is that you have this amazing waterfront, and the mayor has actually recently announced all kinds of really amazing plans for the waterfront for local citizens, which is pretty amazing. But you have this inclusive PPU process, which is this overall master planning process, where it actually engages everyone at the table from the very beginning, run by a local nonprofit group that represents all kinds of different stakeholders by having complete transparent and open conversations about what is possible. It's also possible that there could more possible, I keep saying the word possible, this tram about making sure that we increase mobility in the area and try to find ways that you can actually have less cars on the street because you have a better service to public infrastructure. Speaking about infrastructure, since this is an industrial older site, it is not meant for any of the new uses that some of these developers are putting on these properties, or at least hope to. So what's really exciting is that you can build it from the very beginning. And I think that today you'll hear some things from the students about really what they're going to do with this green infrastructure and opportunities to present to the city, to make the city even think a little bit beyond what we're used to doing in Montreal, but things that are best practices around the world. The willingness really here is to create an eco-district, an Eco-Quartier, the first of its kind in Montreal. Michael? So we talk about this yield development playground, and we started with like 8 different ideas of what we really wanted to do on this site as a prototype. And so we're looking about energy and water systems and waste policies, community engagement, construction materials, biodiversity. It was like, how are we going to bring plants back onto the area? The situation is that we really want to be able to look at how can the developers work collaboratively to create a low carbon net zero community. But it does take a whole village. That was my play on words. Michael, go ahead. So when the intention starts with a low carbon city, you have to start looking, as I discussed, around shareholders, but also the stakeholders. So I kind of put it into a little bit of a category section. So heritage protection, you know, the Dominion Bridge site is where they built the first bridges to connect all of Canada to make our country. Like, that is a story that needs to be told. It's not the buildings that are so beautiful. It is what happened inside the buildings. It's the workers that work together. It's the First Nations that worked alongside the entrepreneurs who came up with some really amazing engineering strategies to build these bridges across Canada. the engaged citizens groups and community groups that I was speaking to you about. You know, there's Imagine Lachine-Est, Concertation, CIDEC, GRAM, Vivanville, le Centre Écologique Urbain de Montréal. These groups all participated in these ateliers, and it was pretty exciting to see what their ideas were on the different themes. Citizens were also included. The developers were at the table. That usually doesn't happen. Usually the citizens don't want to hang out with the developers, and the city is concerned about having conversations that are not transparent. By having this inclusive PPU process, you actually have the developers at the table with the community groups, the citizens, and the different people from the city center, from the city of Montreal, but also the borough of Lachine. What's exciting is that now, with the university research that you're going to hear about today, we now have the opportunity to look at best practices. What can we do that is different than what other cities do? And how can we actually use the research from the CIRC program directly to be able to influence how we can actually build a potential of an Eco-Quartier in Montreal? Michael? The community goals were very clear and outlined very early on. I think even maybe 7 years ago. Maybe the mayor of Lachine would be able to give me a better idea of timing, but I feel like it's at least 5 to 7 years. But they really wanted to talk about resilient urbanism, looking at how the site could be a national treasure and respect for the identity of the site. How do we actually create public safety around low carbon? Now with COVID around the corner, or still here, should I say, I think it's really important to look at how do we want to build our cities in the future. We want human scale, we want to have biodiversity. These are a lot of community goals, but how do you make them happen? Next, please, Michael. Our challenges and opportunities are basically mirror images. So short-term profit now, long-term thinking and commitments. What's in it for me? What am I going to make? As an example, that can be answered by any of the stakeholders. But can we look at cost benefit and actually look at a collaborative approach in a very different manner? So you have the developers and investors and the lenders, they all have something to put at the table. But can we make the business plan work to actually build an Eco-Quartier where it could be a win-win situation? The use of, zoning. What are the uses of the buildings that will be in there? Should we only have residential? Should be mixed use? What is the definition of mixed use? How much mixed use? For whom and for what reason? And the whole concept bonus density that would maybe be able to pay off some of the additional costs that are associated to building an Eco-Quartier. It's never been done before, so the learning curve is steep. However, being able to prototype this and have university research behind it, having the city at the table with all of these different consultants, I think that we could do something pretty amazing in the next steps. But we need to also figure out how is success defined in those next steps. Michael? Best practices in the how do you make it happen, right? So it has to start with inclusive design thinking from the very beginning. Inclusive meaning everyone at the table trying to figure it out, like hacking what an eco district could actually be. Then when you actually build it, what are the best practices on green construction? What are the materials? What are the different types of sun studies and angles and roof systems and all kinds of wonderfulness? But sometimes we also forget that once it's all built, we also need to make sure that behavior of the people who are the end users are influenced by the Eco-Quartier, and to make sure that they continue having composting strategies, lower attachment to people's cars by actually creating a walkable neighborhood, that everything that you can have in the area is 10 minutes away. How can we make that happen? So today we're also going to talk about some best practices. Michael? Nope, one last slide. There you go. So now what? We always talk about thinking inside the box, outside the box. What about if we just break the box and make new rules? How do we value engineer the possible and get rid of that business as usual? How do we prototype profits that values the end users as well as the investors? And in my fun little ending, what bridge will you help to build us to make sure that an Eco-Quartier can be built in Lachine East? And so I'm going to leave this off by saying I'm really excited to hear what the students have to say about the projects coming up. I'm done.
Right. Thank you very much for your great presentation. So I obviously want to thank you very much for organizing the process, and Maya as one of the main leaders. But we also had I would say, around 30 external experts in the course of 3 weeks, and some of them are connected. So welcome all the external speakers. I mean, I think you did a really great job of introducing the challenges that you face in practical life to the students, so that whenever there are figures about energy consumption or CO2 reduction, that we also think about cost and feasibility of getting it done. So I think that was very valuable to have all the input from the external speakers. We had some great workshops on community energy planning, on building constructions, on wastewater treatment, and so on. So I would really like to thank everybody who could make it to that course, who contributed. It was very valuable for all of us. I learned a lot, so that's the best. I mean, if you do a course yourself, and you learn the most yourself. So that was a very nice result of that course. But I think now we start with the students. We have them organized in 4 groups. And before we start, if Michael could share the screen, we did a site visit, and we just, without words, let this little video run, and you see for yourself what we are talking about in terms of Lachine-Est. Okay, thank you very much. In fact, that was not a professional photographer. We had a student who just came along with a drone and made this movie. So thanks a lot to Jimmy Barkos Burgos, who flew this drone and made this amazing little movie. So you got an impression of the site, and now I think we go into the technical details, and I hand over to the buildings group.
Good afternoon, everyone. Around the world, cities are undergoing the biggest growth of the past 100 years. More than 1/2 of the world's population now live in cities, a proportion that is expected to grow significantly by 2050. To support this urbanization, trillions of dollars are flowing into communities. Cities are making significant investments to build and improve neighborhoods, commercial districts, as well as critical water, energy, and transportation infrastructure systems. The whole vision for an Eco-Quartier, as Natalie already mentioned, goes way beyond the planning phase. The vision focuses on 3 major aspects of a district: equity, resilience, and climate protection. Districts that embrace equity ensure all their community members have the opportunity to participate, lead, and thrive within the community. Resilience, on the other hand, ensures that districts are prepared for social, economic, and environmental shocks that may occur. Lastly, climate protection, which ensures that district teams build a pathway to carbon neutrality. We can move on to the next slide. Thank you. Cities are responsible for 70% of the world's energy consumption and the associated environmental impacts. In Canada, the built environment accounts for 25% of energy use. In order to improve the performance of the energy systems of cities, An evaluation of the entire energy system performance is vital for an energy-driven planning. This evaluation is referred to as urban building energy modeling. Next, please. So, based on the vision for an Eco-Quartier in the context of Lachine-Est, our group has developed 4 major objectives, including the development of energy-efficient spatial designs, the recommendation of efficient construction materials, the design of automated workflow for urban building energy supporting system, and the analysis of impact of urban structure on pedestrian comfort. With these goals in mind, the urban building energy modeling workflow provided by our group is divided into 3 main parts: the input data, the process, and the output. The input data includes the information needed for the design of new buildings, such as spatial and envelope analysis, as well as details related to the existing buildings, such as geometry, construction material, and occupancy data. Once the inputs are defined, the next step includes the simulation of building energy demand. Through the simulation engines, we are then able to extract an estimation of heating, cooling, and electricity demands of the urban case study. Then, with the outputs of the buildings group workflow, the energy systems group is then able to move on with focusing on potential renewable sources for the site. So now I'll be handing the mic over to Azin to give us some more details about spatial analysis.
Hi, thank you. Now we're going to talk about the site and introduce it a little bit. The site is special for the city in case of historical character and identity. Considering the strategies and decision, there are some valuable buildings which is important to keep in these sites. More than these buildings, there is a heritage green space shown in the picture with the text with the heritage park. And if we follow the location of the tramway, which is the red line, in this area beside of the recommended pathway, which is the yellow dashed line, there is an area in the middle of the buildings that provide us a lot to use it for this project. This space guide us to prepare some special design respecting the total floor area for various activity in community scale. Next, please. To meet the design requirements, 4 main scenarios are designed by the group, and each of these scenarios meets different concerns like PV potential, energy consumption, maximum PV potential, and maximum green space area, high or low density buildings, and each of these factors considered in each these scenarios, and we designed 4 different scenarios. The requirement of all of them is to reach to the area needed for residential offices, retail, and parks, and all of the scenarios respect the context heritages and which are located in this site. Based on the definition of the Eco-Quartier, offices and retail spaces are considered among all of the buildings. Next, please. Heading to the first scenario, in this massing model, minimum roof PV potential is considered, but as the result, there is more space for green spaces. In this scenario, 85% of total area is residential building as it needed, and the ratio of the footprint is 0.3. Heading to the scenario 2. Next slide. It's again a geometrical design considering maximum PV potential, opposite to the first one. And we can see that the ratio of the footprint to lots are more than the previous option. And if we just take a look at the heating and cooling load per square meter yearly, we can see that an energy consumption is less than the previous one, and also the next scenario are coming because it is more dense. Heading to the third scenario, the main goal is to keep the detached block with maximum surface areas. In this case, solar irradiation can be maximum, and the solar irradiation calculated on the facade of the building. Green space can be considered as a number between scenario 1 and 2, and here we can see that in this model, the energy consumption per square meter is more than the last scenarios. Heading to the next slide, we can see that there are more parameters in each scenario that can be studied, which can make our model more detailed. Like by changing the height of each scenario, we can reach to the sub-scenarios, and with studying them, we can reach to the new scenarios. And this pattern can be considered for all 4 scenarios, but here we considered the scenario 3, and using the software like Rhino, making these sub-scenarios much easier. And here, as a sample study, scenario 3 is chosen to be studied by more detail with almost 4,000 different iterations. And in the next slide, there is a video that by changing the height and location of each building, we reached to more than 500 different scenarios, and the video shows the solar optimization using genetic algorithm. But why solar optimization? Because more solar radiation on building surface can be highly effective in cold climates like Montreal. So the purpose of the project is to determine the optimum height with the acceptable range, which is provided by the City Council. And this range is something between 6 to 16 floor. At the same time, we kept the floor area constant as it's needed for this project. The fitness indicator for the process was to sum of the solar irradiation received by the roof and the south facade of the buildings. Even though scenario 3 has the highest energy consumption among 2 other scenarios, but after the optimization, we reached to a model that its energy consumption reached 10% less than the first one. And heading to the scenario 4. Next slide, please. Thank you. The last scenario is scenario 4, with the main concern of respecting the context, heritage, and adjacent neighborhood while providing efficient energy design through high level of compactness. The factors that were important in this design was the compactness factor, the ratio of the floor area to footprint, which is equal to 6.63, and the ratio of total envelope surface to floor area, which is 0.65, and the ratio of height to distance between the building, which is minimum 1. And we have a video of one of the scenarios in the next slide. It's an overview that if we, all of those scenarios can be modeled, but in more detail. But here, in this scenario, we can see that with the respect of current heritage building, we design building envelope respecting the level of height for adjacent neighborhoods, required distribution of floor area and activities. The concept of Dominion Bridge leads us to provide a landmark building, which is visible from various perspectives in distance and urban corridors. In case of energy efficient design, we applied high level of compactness in horizontal and vertical axis. In addition, we applied various measures of building setbacks in the height. So in that case, we kept the shadowing of the building in each other on the lower level. Furthermore, we tried to follow the nature of Eco-Quartier, and by providing 70% of ground floor, which with open and green spaces, which are accessible for visitor and community through walkways and bicycle ways. Here you can see more renders and more view from the site. And thank you.
Yes, as we want to put, previous slide, please. Yes, as we want to put new buildings in the site, it is reasonable to consider their effect on microclimate, since they can change the airflow pattern, and this can change the pedestrian comfort criteria, including the thermal comfort, wind comfort, and pollutant concentration within the urban area. As you can see in the right side of the slide, different fluxes of different heat fluxes, and also different sources of pollutant. Also in the middle, you can see the effect of wind within an urban area, and all of these phenomena are important when they are located in the lowest part of the atmosphere, which is called atmospheric boundary layer. And in the lowest part of the atmospheric boundary layer, which is called roughness sublayer, there is a complex interaction between the airflow and the surface roughnesses, such as buildings. So by considering this complex interaction, we use computational fluid dynamics, or CFD, for analyzing the impact of different scenarios by considering the height variations in buildings to see the impact of the height variation, and also the inlet velocity on wind comfort and pollutant concentration within an urban area. Let's go to the next slide. In the first simulation, I used the scenario number 3 by considering the height of the new building as a constant, and we will consider the height variation of in buildings, and the velocity of 4.6 meters per second at the height of 10 meters above the ground, and the wind direction from north to south, as you can see in the slide, from left to right. Here you can see in the left side of the slide, you can see the contours of the dimensionless velocity magnitude, and also in the right side of it, you can see the contours of the dimensionless concentration. And if you consider this simulation and go to the if we go to the next slide and see the we can see the, let's go to the next slide. No, previous one. Yes. Now we can see the impact of height variation in the same scenario. As we can see here, the wind velocity decreased in the site, and also the pollutant is more accumulated within the urban area. So we can see that the height variation in urban area is a mitigation factor for and the wind comfort mitigation strategy for wind comfort criteria, but it can exacerbate the situation for the pollutant concentration within an urban area. And in the next slide, let's go to the next slide. In this slide, we considered the impact of inlet velocity on pollutant concentration within an urban area, and as you can see here, the impact of wind velocity in dispersing the pollutant within an urban area is significant. Thank you.
I'm going to talk about the construction material. Envelope design considers the energy performance of a building construction assemblies. So for achieving a high efficiency building, we need a significant focus on the thermal insulation of the construction and reducing the number of thermal breaths and keeping the degree of air tightness in joints and cracks in the structure. To cover all objectives, we could apply a high energy performance standard for new buildings. Two options are suggested, which we started with the ASHRAE 189.1, since it is available with a high level of detail as an open source data on the NREL website and could serve our UBM system. In addition, since some of buildings would be preserved in site, we recommended refurbishment scenarios for total construction assemblies or just windows and walls. In this case, we follow the reference standard of existing layers. Next slide, please. Speaking of building envelope, we have looked more in depth into external wall insulation and how it can impact a building in terms of energy demand and environmental impact. To do that, we have looked at wall insulation from two different perspectives. On one side, we have building standards such as ASHRAE, which exists to set minimum standards for the building envelope. And we also have standards used to obtain a passive building certification, for example, FIOS, which represents one of the highest envelope standards. In addition to the building standards, we have the insulation materials. We all know that there are multiple types of material that can help us reach those standards. But when it comes to environmental impacts, each material has its distinct impact. Next slide, please. To help in the visualization of these two aspects, a stereotypical high-rise apartment building was simulated within the climate conditions of Lachine. By manipulating wall insulation R values within the minimum and maximum standards, it is important to point out that by increasing the R value from the minimum standards, more energy can be saved. But more insulation material will also be needed, which contributes to more embedded carbon emissions. Based on the 5 different insulation materials shown in this graph, we can see that both neorate board and the wood fiber materials show lower carbon emissions, emission payback period when comparing them to the other 3 materials. Next slide, please. In this slide, I wanted to explain about the impact of green roof in energy conservation and CO2 emission. Roofs have nearly 20 to 25% of overall urban surface areas. Therefore, the green roof and facade could be a sustainable solution for energy consumption and greenhouse emissions. Based on green roof construction standards and thermal properties, Block A in scenario 2 was simulated by Green Roof Energy Calculator, which is an online tool for comparing the annual energy performance of a building with a vegetative green roof to the same building with either a dark roof or a white roof. As you can see here, the energy saving benefit of green roofs is not significant when compared with white roof. For investigating the impact of green roof on CO2 emissions, we should consider life cycle assessment of the green roof. The CO2 emitted during the production and maintenance of the green roof is offset through CO2 sequestration and energy saving after 5 to 15 years. Thank you. Now Surush will take hand the rest part.
Following the methodology, we have developed an air-band building energy modeling system within the CERC research group, which has been applied to provide the demand analysis on the different proposed condition. The figure that we see is the structure of the UVM system. Next slide, please. Here we try to understand the effect of different materials and construction on energy demand. As we can see, using the high performance materials and construction like ASHRAE 189.1 leads to less heating demand, something around 50%, because here we just compared it with the energy plus default, which we can see in a specific heating demand figure and total heating demand figure as well. Next slide, please. So this figure shows the effect of insulation thickness on heating energy demand. We just wanted to change the insulation thickness to see its effect on heating demand. As we can see, increasing the insulation thickness by 20% leads to reduction of 20% in heating demand and peak heating demand. Which we can see in a specific heating demand and total heating demand figure as well. Next slide, please. So this figure shows the effect of window-to-wall ratio on heating demand. As this figure shows, decreasing the window-to-wall ratio by 50% leads to increasing the heating demand by around 15%. So as we can see in a specific heating demand and total heating demand figure as well, we can see on that figures the result is the same. Next slide, please. So here we try to, these are just some preliminary results and based on the what we taught and explained before, we try to compare different strategies together to see which one has more effect on heating demand. As we can see in this figure, some strategies like using high performance materials or changing insulation thickness or changing window-to-wall ratio, as we can see, the insulation thickness has the most effect on heating demand, which shows the least heating demand result. Next slide, please. So in this dynamical simulation that we have done, we tried also to compare different scenarios together because we had, as Azim explained, we had different scenarios of geometry. So with different airband, with different densities, so we try to compare the heating load of these two scenarios, two scenarios as well. So as we can see, one of them has less heating demand compared to the other one, and one of them has more facade over floor area ratio compared to the other one. This is what we can see also the same result in specific heating demand and total heating demand as well. Next slide, please. This table shows the total energy demand in details. So what we estimated from the site, we calculated from the site, for example, the heating demand in kilowatt hour per meter square per year, and cooling demand, plug loads, electricity, total electricity for heating, total electricity for cooling, total plug load electricity, and district electricity. Also, in another table, we can see the U value of different parts of the geometry, the buildings, and also some general information that we use for this calculation. Thank you. Next slide.
Okay, so to wrap up our group's presentation and hand it over to the energy systems group, I would like to summarize the criteria that we believe are important to consider when planning an eco-quartier. In the spatial design topic, our group recommends more compact designs as they can reduce energy consumption up to 69%. These high densities, however, can reduce the surface area available for PV systems on the roof. Based on our findings, designers should also look into passive solar gains for reducing heating demand, which can be reached by using different building heights within the district. Next slide, please. On the pedestrian comfort side, we have found that urban heat island effect can be reduced by green spaces and by increasing wind speed through channeling. And in order to efficiently design for high air quality in districts, surrounding pollutants should also be taken into account. The next slide. And lastly, when it comes to the building materials, we have found that high levels of insulation can minimize heating demand. As an example, different analyzed scenarios have found that electricity demand estimations can reach up to 10 times lower consumption than an existing district by changing building materials. Also, choosing materials with low embedded carbon are important for overall CO2 balance. For example, replacing concrete with massive timber strongly reduces the embedded carbon. And finally, our group recommends new ideas such as green facades to be considered in cold climate places such as the Lachine district. And with that, I hand it over to group 2.
Okay, thank you very much, group 1. I mean, thank you very much for the incredible work. I mean, it's a lot of material. So before we go to group 2, we obviously would allow some questions now, because probably after 4 groups, you won't be able to remember what has happened now. What I wanted to say, I mean, I think it's now the first time that the student team really managed to get a full workflow working, starting from an empty site, creating 3D models, assigning all the construction materials to these 3D geometries, and then automatically calculating the energy demand, including shading and even microclimate. So I think that's the first time we managed to get this done after a year of the CERC operation, I would say. And the results just came in literally 1 hour ago. So I think you did an amazing job of getting it to work and producing some numbers which look reasonable. And I mean, this factor 10, I mean, compared to, we got some data from Ontario for a similar size district, 10,000 people, and scaled it down. This factor 10, bringing down the demand factor 10 is a huge challenge, because it means touching everything, the material construction, but also appliances, coming up with an appliance frontrunner program to incentivize people to buy actually appliances which are very energy efficient. So it won't happen by itself. So we need to continue discussing of how we can get to these sort of beautiful figures that make a zero carbon district possible. But I mean, are there any questions just now from the audience? I see a hand raised from Maya. Maya, if you...
Yes, I would like to know about the green roofs. There was some energy calculation about that. Could you tell me more between white and a green roof? What was the difference?
The white roof, it means that covered with the bright material and white. And you want to know the comparison with the vegetation roof and white roof?
Yes, because there was something about energy cost or energy efficiency.
Yes.
And I never knew about, I knew it was greener, but I didn't know it would affect energy heating, or I couldn't understand what you meant.
There isn't any significant detail, amount of heating, you know, just somehow in the cost and in electricity. But in heating demand, because of the Montreal weather data, we couldn't reach the significant number that...
it doesn't have that much effect in the cold region.
Excuse me?
Yes.
I mean,
it doesn't have that much effect on heating and cooling in cold region, but we can consider it for other things like
CO2 emissions or other things, or maybe agriculture side, you know. But we just simulated on the high-rise building, and if we just put it in the lower height, maybe it works. It's going to be work.
Just to comment on this, I mean, all these roofs would be insulated anyway. So whether you put a green roof on top or just a sort of highly reflective material, it doesn't really make much difference on heating. But yes. I mean, these white roofs are now becoming quite fashionable, more for summer conditions, to reflect more radiation to keep the roofs cooler. But I mean, we will send you all the detailed reports. I mean, also the green roofs obviously reduce temperature levels on the roofs. So actually the energy impact is not big, as Sari said. but we hope there's an impact. I mean, there will be more an impact on air quality and microclimate than on building energy consumption.
I think we should see the big picture and see the, I don't know, the big vision of 50 years and 100 years after we apply the green roof, and what's going to be happen after this time. And, you know, the life cycle assessment of green roof, because the impact of the, in the microclimate, I think it should be considered.
Also, it can exacerbate the situation when considering the green roof during the nights, because the heat can be trapped under the greenery spaces, and also increases it can increase the heating demand at nights. Yeah.
All right. So Leon Wang has a question.
Yes. Hi. Hey. Hi, Ursula.
Hi, Leon.
Okay, nice work. I know Shahin is working on the microclimate and demodeling. Just wondering, well, they're very nice pictures. So what tool did you use, Shahin?
I used ANSYS Fluent.
So at this moment, you're using ANSYS Fluent?
Yeah.
So any plan, we've been talking about using CDFFD, any plan to use it for your next step?
Yes. I had conversation with Mohammed about it, but he's now in Iran, and when he comes back.
Okay, great. So glad to know that. And also Azin, she did a great job on this Rhino stuff.
Professor Wang.
Yes,
thank you.
Hi, Azin. Good.
Okay, thanks, Leon. Maybe one last question from Arian Weeks.
Hello. I work at the Center for Creative Reuse at Concordia. I've experienced the green roof for the last 15 years on a home in the Eastern Townships, and it's been a great resource. And I particularly bringing green space back to a place where there might not have been before. So I would add that on to the notes of the students. I'm wondering, and I know this might be hard, but considering we're in the middle of COVID, did any of that factor into the spaces in and outside of the buildings that you were looking at, that you were designing? Considering there's research, very, very new research coming out about internal airflows within buildings, and just, yeah, making sure that we have enough space to get in and out of buildings, considering the space that we need to move around during COVID.
Good point. Does anybody want to answer? Otherwise, no, I mean, we didn't go into sort of details of changing parameters in the building energy modeling, like airflow rates and what impact that would have on electricity consumption, because we wanted to get the urban scale workflow moving first. But now we have it, and so it's now very easy to change parameters in the building energy models. So I think what you mentioned is very important, and we can now easily change airflow rates and see what impact that does, that has on heating and cooling, and obviously electricity consumption of the buildings. But the goal was, it was already a lot of work to get the overall model to work, and now we can go, I mean, that's exactly the goal of all this parametric design, that we can now change easily all the parameters, and that's for sure one important one.
Well, thank you. Great work, Group 1.
Yeah. May I add something, Ursula?
Yes.
So basically, for outdoor, the risk of infection is pretty low. For indoors, we have low ventilation rate. It's related to the particle size, the social distancing, the people occupant density, and also ventilation rate. There's a recent paper, it's ongoing research about evaluate the risk under different ventilation efficiencies and distance. And if you're interested, I can share the paper with you.
Sure, put it in the chat.
Oh, yes, I'll do that.
Okay, great. So let's keep moving, because we've got 3 groups to go. And so based on what you've seen, I mean, this sort of overall ambitiously low electricity demand of 10,000 megawatt hour, Group 2 did some design of energy systems, and I hand over to Group 2 to present their results.
Hello, everyone. My name is Said Rangerber. I'm the leader of Group 2. The importance of moving toward renewable energy systems from conventional fossil fuel systems is not hidden to anyone anymore. You see in these graphs that variations and increase in global temperature of the world, and also the increase in monthly mean carbon dioxide emissions in the world, which means that we have to use renewable energy systems which emit much lower carbon dioxide and greenhouse gas emissions. Next slide, please. These greenhouse gas emissions bring different challenges like deforestation, global warming, and things like that. And our solution is utilizing more of renewable energy systems in our power grids and heating systems. Next slide. There is a strategy in Quebec province for adopting renewable energy systems. Quebec has adopted a greenhouse gas emissions reduction target of 37.5% below 1999 levels by 2030. Its 2030 energy policy aims to increase renewable energy generation by 25% and decrease fossil fuel use by 40% over the next 15 years. Quebec's GHG emissions in 2017 were 77.9 megatons of carbon dioxide equivalent. Quebec's emissions have declined 9% since 1990. The Eco-Quartier Lachine-Est, one of the 5 planned zero carbon districts in Montreal, is in the same direction as Quebec's plan for 2030. Quebec's emissions per capita are the lowest in Canada at 9.4 tons of carbon dioxide equivalent, which is 52% below the Canadian average of 19.6 tons per capita. Next slide, please. So in our group, what do we have in our mind for an eco-quartier? First of all, and the most obvious one is using more local renewable energy generation. And then an eco-quartier in our idea uses energy systems with low carbon emissions. Also, we believe that to reach the target of Eco-Quartier, we should increase the awareness and participation of public in local energy generation. And also, we should have open data owned by citizens for smart energy management. Next slide, please. All right, I will leave the presentation to Nabil now.
So good afternoon, everyone. My part in the energy team here is to study the photovoltaic generation possibilities in the new Eco-Quartier in Lachine-Est. So what I did here is that I started with a preliminary assessment of the photovoltaic potential in the Dominion Bridge area. And after considering the data provided by Natalie and the scenarios by our building team, I calculated the possibility of generating 34 to 50% of the total energy supply for all the future buildings in this area. Next, please. So since it's all based on future plans that might eventually change, I decided just to focus on one building just to get more precise perspective on this. So one of the buildings that will not be demolished is the Civic Center, a 3-story building intended to be turned into a multi-office establishment. Next, please. So the first step here was to calculate, or in this case, to estimate the daily consumption load of all these offices in the whole building. And naturally, this includes different electronics and appliances that are usually used in offices. Next step was to use a simulating software to show the consumption load profile, to optimize the tilt angle according to the area, and finally, to get an estimate of the system capacity. Next, please. The results showed that using 80% of the building's roof area was sufficient to provide almost 42% of the building's main energy demand. And moving on to the cost, the system is estimated to cost about 80,000 Canadian dollars with a payback period of almost 10 years, considering the local electricity rates here in Quebec. Not to mention that the life cycle of the solar panels is 20 to 25 years. That's it. Thank you so much. Next.
Hi, I'm Hadis, and I'm a PhD student, and today I want to talk about wind energy and also wind turbines. First of all, I want to talk about wind energy, and as you can see in this slide, we have the diversity of high, and according to high, we have the average wind speed, which is changeable to the according to the high. For the 10 and 50 meter, which is appropriate for installing vertical axis wind turbine, we have 4 to 6 meter per second wind speed, but for 100 to 150, which are appropriate for installing horizontal axis wind turbine, the wind speed is equal to 7 to 8 meter per second. Next, please. Also, in this slide, I want to talk about a horizontal axis wind turbine. And as you can see in the picture, which is located in the right of the slide, you can see the onshore wind turbine, which its capacity is approximately 2.5 to 3 megawatts, which can produce more than 6,000 megawatts in a year. But in the next picture, you can see the diversity of offshore wind turbines, and each of them can produce 3.6 megawatts that can produce around 8,000 megawatts in a year. So according to the electricity demand in the Damin Bridge site, if we will install 1 offshore or 2 onshore wind turbines, we can cover the demand electricity completely. Please, next. In the spring of 2018, Avisio Council released a report titled "The Economic and Financial Impacts of Wind Farms Operations for Quebec Communities." According to this report, not only does create a company 500 jobs and attracting $10 billion in investments, but also the wind energy sector in Quebec provides annual revenues of $120 million to project communities. But the question is, what are our suggestions? The first one, we should consider that the citizens should be allowed to own a wind turbine or invest in a wind turbine project. Next one would be the government or Hydro-Quebec should guarantee a fixed amount of revenue for the investors per kilowatt hour. And the last one, if the companies should be able to invest in such a project, instead the government should reduce their whole tax or at least a portion of it. Please, next. In this slide, I want to talk about various vertical axis wind turbine. As you can see in the picture, which is located in the right of the slide, you can see the diversity of vertical axis wind turbine. But in this project, I investigate the H-type rotor vertical axis wind turbine to calculate its energy capture. Please, next. I considered a lot of scenarios, but I put the best scenario in this slide that indicates the energy capture of four seasons in a whole year. And I calculate an energy capture based on the average wind speed, hourly average wind speed. So for a spring, the total energy capture is equal 192, and for the summer, fall, and winter are 121, 206, and 275 respectively. So the annual energy capture would be 794 kilowatt hour, according to the average wind speed hourly for 4 seasons in a whole year. Please, next. According to the total available area in Lachine-Est, which is equal to this value, I calculate density of wind turbines by knowing that the radius, the blade radius. And after that, I calculate potential number of vertical axis wind turbine, which is necessary for meeting the electricity demand. So the total energy capture from all wind turbines is equals 670 megawatt hour. So the question is, what is the cost of purchasing this vertical axis wind turbine? As we can see, we have some important components such as wind turbine, MPPT charge controller, pure sine wave, inverter, tower, support, and battery. So the total for one unit is equal $4,000 to $5,000. And if we considered 844 vertical axis wind turbine, so the total cost is approximately $3 billion to $4 billion. Thank you.
Navid?
Yes, good afternoon, everyone, and hi. In order to supply the required and provide heating and cooling and electricity for the area, we need to design the systems. And before I start with the distributed heating network and also the integrated renewable system, I just want to mention a summary of the sizing of heat pumps and geothermals. So as you can see here, using a geothermal plants in order to produce heating and cooling has some advantages about the operation cost is much lower than the groundwater temperature. And also the capital cost and the land area requirements is much lower than the GCHP systems. So go to the next slide, please. So here in the, as you can see here, the map of the area that we want to work on, and we are working actually on the building B and G, as you can see here on the map. And for the sizing of the geothermal plants and actually for the sizing of the heat pump that is using geothermal plants, we have two scenarios. That is one with geothermal and the other is using the electricity from the Hydro-Quebec. And if you go to the next slide, please, these are the, actually we use the UMI software in order to find out the demands of these two buildings, building B and building G, refer to the roof area and the other parameters that we gave as a feed to the UMI software. And as you can see, the result for the building B is about 1,400 megawatt hour per year, and for building G is about 600 megawatt hour per year for the cooling and heating demand, both with together. Next slide, please. So here you can also see about some economical analysis and the price of the electricity, levelized cost of energy actually as the Canadian dollar per kilowatt hour. And if we compare this with the scenario that using electricity from the Hydro-Quebec that is averagely about 9 cents per kilowatt hour, it's a little bit, it's much lower than that. So next slide, please. So here, as you can see, let's talk about the heating network, district heating network, that is very important. So when we are talking, as you can see here, you can see node 1, node 2, node 3, node 4. So node 1 is the power generation unit, is the generation unit, so that produce heat for us. And node 3 and node 4 are the B and G, building B and G. Actually, node 3 is building G and node 4 is building B. So as you can see here, this is a very small heating network, but if we want to make it for bigger networks, we need to have lots of other presumers. Presumer, it means that they can produce heat and also consume heat in the same time. And this has lots of effects on the system that will be investigated in our future research. But for now, for just this little small district heating network, as you can see here, the building G, actually, the building G, that is building 3, actually acting as a presumer here. So it can produce 42% of its energy demand by renewable solar energy, I mean the heating demand. And also the other scenario is not being presumer. So we have 2 scenarios. First one is no presumer, not 4, not 3. And the other one is 1 presumer that is building G, building 3, that is very near to the node 2 as the junk node. So if you go to the next slide, please, you can see the results of the first scenario. This is the first condition, that we have no presumer. And as you can see, the temperature and pressure in different graphs. The blue one shows the supply line, and the blue one shows the return line, and the red line shows the supply line. You can see that from node 1, that is about 75, to node 2 and node 3, actually, the node 3 is a presumer. There is a distance. In node 3, we have about 72, and in node 4, it's about 71. And also we have the pressure. We have some reduction in pressure as well. As you know, the nodes are connected by pipes together. So from the generation to the nodes, so for sure the pressure will be dropped. So, but for the second scenario, if you go to the next slide, you can see that this reduction in both pressure and temperature, as you can see in node 2, from node 2 to node 3 and 4, and also in the pressure from node 2 to node 3 and 4, especially in node 3, I'm not talking about node 4. From node 2 to node 3, here we don't have any changes, because the most amount of the heat is provided by the node 3 himself. So it means that if we use the presumers, if we consider the presumers in the second scenario, it means that the drop of the temperature is very less, and the drop of the pressure also is somehow 0. So if you go to the next slide, please. This is the, and now we want to provide electricity for our area. So we need to integrate the renewable systems. We talked about renewables as standalone in each slides before. Now we want to integrate them together and do the optimal sizing. So as you can see, we have 3 scenarios here. 2 of them I will show you here, and the next one I will show you in the next slide. So in the scenario 1, is for the whole area of the Lachine with a population of more than 44,000 people. So it's a big area, and as you can see here, there are top 3 configurations you can see here for the PV, wind turbine, biomass gasifier, and also converter, battery. These are our components. And the best scenario, as you can see, is using all of the components together. PV, more than 300,000 kilowatts, wind, 5,000, number of 10 kilowatts, and biomass gasifier, that is the size is about 100 kilowatts, 100,000 kilowatts, and it's using the municipal solid waste that is produced in Montreal. So I don't want to go too deep into the components. Just as you can see here, the net present cost of the system is $1.6 billion, and the LCOE, or levelized cost of energy, is about 20 cents per kilowatt hour. So if you consider the same system, the same components, I mean, for the eco district that we are talking about, that somehow the population is about 10,000 people, the configuration will be like this. We need 80,000 PV, 1,000 turbine, and 50,000 biomass gasifier, 50,000 kilowatt of biomass gasifier plants. And at the end, the cost of energy will be about 19 cents per kilowatt hour. So these are the best parameter configurations here. And at the end, if you go to the next slide, please. Okay, first let's discuss the scenario 1 and scenario 2 renewable penetrations. You can see it's very easy to, you can see it here that the PV, the wind turbine and biomass are changing. The penetration of them in the integration can change in the winter and the summer. In the summer, we have lots of radiation, so the PV is much more. And in the winter that we don't have any kind of radiation, we have a smaller amount of radiation. The amount of biomass gasifier production is higher. So for scenario 2, again, the same thing will happen. And if you go to next slide, please, you can see that we considered for scenario 3, that is an eco district, again, with 10,000 people. But this time, we consider that each building, the demand of each building is half of the previous one, scenario 2, because we consider the high efficiency building. So with a half consumption. So here, again, you can see the top scenarios with the PV with 30,000, more than 30,000 kilowatts of PV, 300 wind turbine, and 8,000 biomass gasifier. And at the end, the MPC is about 175 million USD, and the cost of energy is about 19 cents per kilowatt hour. That I think it's feasible. And also about the renewable energy penetration, you can see here again in the winter we have less radiation and much more biomass, and in the summer we have more radiation, so we have more PV power generation and less biomass generation. And I want to mention this, that if we consider the first scenario here in the top, in a scenario 3, if we consider the first configuration as the best configuration, you can see that the price of electricity is about 19 cents per kilowatt hour, and the price of electricity in Quebec is about 9 cents per kilowatt hour. So Quebec has the cheapest electricity in all provinces in Canada, but we should consider that if we want to expand the electricity grid from the Hydro-Quebec inside of the district, we need to consider the price of the grid expansion per kilometer, and then add it to that 9 cents per kilowatt hour. So at the end, it's possible to compare it with this amount that is 19 cents per kilowatt hour. So I think if we consider that in our future study, we can see that this system is economically and environmentally feasible. And if you go to the next slide, you can see that the environmental emissions of this system that is designed for the 3 scenarios, scenario 1, scenario 2, scenario 3, the emissions are very less. And if you just click one more time, yeah, you can see that, just for your information, a typical average coal power plant can generate lots of CO2 emission, more than 1 million tons per year. So if you consider it with scenario 3 that produced 9 tons per year, so it means that the emission actually is somehow 0. So we are talking about a 0 emission or integrated renewable system. So next slide, I think Said should continue. Thank you so much.
All right. Now by far we have talked about conventional renewable energy system. Now we want to talk about innovative material for renewable energy generation. Piezoelectric generators are kinetic energy harvester and offer a robust and reliable solution by converting normally wasted vibration energy in the environment to usable electrical energy. We can use piezoelectric wherever people pass by more like public places, as you see in the picture, like building lobbies, bridges, park and public places, public building, metro station, and dance clubs. Piezoelectric cells create energy self-sustained projects and produce energy from people walking throughout the facility. Next slide, please. With all the footsteps in Canada, kinetic pavement could generate large amounts of electricity in the near future. Increasing number of intelligent streets could play a big role in making Lachine an Eco-Quartier. Our mission is to speed up the energy transition by creating awareness about renewable energy. We believe that all technology is available to create a sustainable world. As you see in this table, The cost related to piezoelectric energy generation has decreased from 29 to 2018 because it has its efficiency has increased and awareness towards this system has also increased. Next slide. Right. This part is about connected smart home energy management system. So what is a smart home energy management? It's a kind of intelligent home automation system that connects appliances of a house to the internet and together to supervise on their energy use. And
all right, yum yum, happy camper. I'm just gonna go to the car and see if I can get the connection there, just because it's a little loud here with the truck.
Sorry, Faisal, I guess. It's a kind of intelligent home automation system that connects appliances of a house to the internet and together to supervise on their energy use and optimize their consumptions. It is made up of a main controllers system and lots of smart plugs that measure electricity use of appliances. Now connected HEMS is about connecting multiple HEMs together, home energy management system. This connection can bring remarkable potentials for saving energy. How is it happens? For utilities, residential houses are often like solid blocks of energy consumers that are not intractable. Connected home energy management systems expand the reach of utilities to appliances energy use of every house to understand their usage schedule and to optimize them. Why is this important? Because it stretches the capacity of power plants and prevents or delay building new ones. By unlocking remarkable energy saving potential that is hidden in the home appliances energy use. In this image, which is a concept, if we consider this area controlled by a smart electricity grid, connected home energy management systems can join a smart grid system as a module. This will enable better optimization in the modular and overall level. Next slide, please. The challenge lied in home energy management system is for their implementation in an area like Lachine, there are several challenges. As home energy management systems have many sensors for wide areas, the number of recorded data samples reach to billions, and storing, reading, and doing computation on this amount of data requires specific measures. HEMs doesn't need expensive infrastructures, but as some of sensors work with LoRaWAN, and they need LoRa gateways to be installed in Lachine area. Security and privacy issues is another challenge faced in using home energy management system. At last, a smart grid system should become allied with connected home energy management systems to unlock more energy saving potentials. Here, the slides of our group ends. Thank you everyone for listening to our presentation.
Okay, thank you very much, Said. Yeah, the time is running. We are even a bit over time already. So I think the people who use the energy, do the energy calculations, get a bit carried away with all their kilowatt hours and megawatt hours. So lots of numbers here, but if there are urgent questions, we can have them now, but I do not see a hand raised. So I would prefer actually to go on so that the last two groups still have some listeners before everybody is tired. So thanks again, group 2, for the nice presentation. And I would say we immediately continue with group 3, who's been working on waste management and wastewater. The floor is yours. So who's starting in group 3?
Faisal, I think.
Faisal. What happened? We told him to mute his microphone and he probably disappeared out of the, I don't know what's happening. That's strange. Okay, I would say, I mean, maybe somebody can phone him. In the meantime, I would say we just start the presentation anyway, and maybe I can do an introduction, and group 3 could try to find their missing member in the meantime. So the goal of group 3 was to look at a zero-based strategy for this eco-district, and that involves looking at all the material flows and trying to achieve as close as possible a circular economy idea. So to basically reduce material going to landfill as much as possible. Next slide, please. So the situation just now is that only half of the material in Montreal is diverted from landfill. And the objectives, as always, are very ambitious to divert 85% from landfill pretty soon. So that depends a lot on individual players, on many citizens who need to understand what the material and resource use problems are, how to best sort their rubbish, and even if it's sorted or even if it's collected, to make sure then in the following process chain that the organic material goes to landfill. So next slide, please.
Ursula, just a quick note to say Faisal is back on the call.
Okay, then
Hi.
take over, please.
Can you hear me?
Yes.
Yes.
Sorry about that. Okay.
Go on from here.
So, yeah, no worries. Okay, so you saw the introduction. We're looking to create a zero waste Lachine site. And I apologize for trucks in the background. I'm trying to get to a campsite in the middle of this, but this is the best I can do right now. So what we did to start was trying to estimate how much waste we're going to generate at this site. And obviously we don't know exactly what's going to take place there, but we could come up with some, ballpark estimates of how many people are going to be there. We know around 10,000. They're going to be living in these mid to high rise buildings. We know but there's going to be a certain number of commercial establishments there, offices, and maybe a school. So using some characterizations that have been conducted by Québec, a government organization in Quebec responsible for waste management. Basically, they look in samples of trash and recycling and compost and see how much people are throwing away on average from different sites. And we can apply that to the estimate of the number of people we have and establishments. And so that's how we're going to come up with a ballpark amount of different materials. Next slide. And obviously, there's a diversity of materials we're talking about in this dense area. Everything from a lot of food waste, organics, particularly from the residents, but also from commercial establishments. There might be a market there. So I estimated a couple of markets, stores. Anyway, you're gonna have a lot of organics. You can see the total result when we add it all up. You're still gonna get a good amount of recyclable material. That's a mix of plastic, glass, metal containers, and cardboard and paper. But there's also a lot of construction waste and bulk waste like furniture and other things, textiles, e-waste, and some domestic hazardous waste like paint and whatnot that people might produce. If we want to align Lachine to the ambitious plan that Montreal has, 85% diversion from the landfill, that means we've got to divert 85% of those materials. And so that's a challenge. Next slide. Thank you.
Good afternoon, everybody. My name is Tahira. So I will explain about the background of life cycle assessment. It's a cradle to grave analysis technique, and it is a really necessary and primary step in order to apply waste management systems. So it assesses environmental impacts associated with all the stages of a product's life, as you can see in the figure, from raw materials toward the manufacturing, packaging use, and at the end, recycling or disposal. And also in case of the waste, it starts from the point that materials enter the waste stream and continues until the recycling or recovery or disposal stage. There are many LCA tools all over the world. In Canada, IWM tool was developed by University of Waterloo. And I used it in order to calculate the emissions and energy consumption of different waste management systems in Lachine-Est. Thank you. Next slide. So here you can see the map and the waste generation in different districts of agglomeration of Montreal. There is a huge potential of energy recovery from food waste and yard waste instead of landfilling them, despite the fact that many households are just separating their organic waste, but unfortunately, 23% of organic waste was recovered in 2017, and it is still, landfilling is still the main waste management method, especially for organic waste in Montreal. In 2017, the portion of diverted and landfill waste totally was 45% and 55% respectively. There is organic waste collection in many single-family households, but organic waste accounted for 369 KT, from which around only 85 KT was recovered. And next slide, please. So here, as you can see, there are infrastructures for waste management in Montreal. Actually, they are the actual infrastructures and the proposed infrastructures that the government is planning to install in the city. So if you enter, please, you can see, could you please enter? You can see, okay, so sorry, go to the previous slide. You can see 2 recycling centers in the agglomeration and also 1 composting site and 7 eco-centers, which are actually exist in the agglomeration, but the proposed ones are 1 composting center, 1 biomethanation, and also 2 more eco-centers. So looking through the Lachine district, it has only 1 recycling center, and this is a centralized waste management system which needs a high transportation requirement. Could you please go to the next slide? So what we're gonna propose to Lachine-Est is an integrated waste management system. If we assume 10,000 people will live in this area, and each person is producing 750 gram waste per day, according to the waste composition of the Montreal, so we can assume organics comprises 40% of the waste, including food waste and yard waste. Recyclables, including paper, metal, glass, plastic, comprises 29% of the waste, and the other material, excluding construction and demolition waste, comprises 31%. So the proposed waste management system will include recycling, the maximum recycling, and composting facility, energy recovery facility, including anaerobic digestion and incineration, which later incineration should be replaced by gasification or pyrolysis, and also at the end landfilling with gas recovery. Could you please go to the next slide? So one of the important aspects that I previously explained in Montreal is the centralized waste management system, which needs a very high transportation requirement. But in Lachine-Est, I assumed a maximum, considering the area of this district, maximum 2 kilometers in order to collect the waste or transport the waste from the source to incineration unit or landfill or material recovery facility or composting site or anaerobic digestion unit. However, the proposed scenario that I recommended is 0 landfill. So next slide, please. This is the result, which indicating the less emission by an integrated waste management system. So the CO2 emission in the current scenario of waste management in Montreal and also Lachine-Est is 74% landfill, 17% recycling, and 9% composting. This produces around 1,000 ton CO2. And in a future situation, if For instance, we assume 20% of organic waste goes to composting and the 20% to anaerobic digestion, 0 landfill, the maximum amount of recycling, which is 29%, and also the rest of the waste goes to incineration or in future gasification or pyrolysis units. So the CO2 emission will be somehow halved. Next slide, please. Faisal, would you continue?
I'm gonna unmute myself. Here I am again. All right. So as you can see, there's some decent CO2 saving implications for moving away from landfilling and local transformation of materials rather than taking things to central sites. The first step to a successful waste management plan is proper sorting of waste. And what we found in the past is that it's not enough just to educate people passively on what to put where. It's actually fairly complicated for people to learn the over 100 different items that they might be dealing with on a yearly basis. So some of the best practices we learned at Concordia that I think we can apply at the Lachine site and that are represented in literature as well is you need to make life really easy for people to make the right decisions. If they have to travel a fair distance, they're going to give up and they're going to use the easiest bin available to them. So waste bins need to be designed so that the options are available, but also that the bins aren't too easy to use for trash. So having a wide open trash bin is a no-no. Other things we can do is we can actually, in a mid to high rise, potentially make an organic chute. If most of the food, the waste people are throwing is organics, why not design it so that's the easiest thing to dispose of properly? But yeah, all other options should be there, including some of the lesser common options like e-waste recycling and potentially a reuse collection bin. So this is going to lead into a slide I'll get to in a little bit. But we can also have smart waste bins and smart feedback to community members. Waste bins can have a little bit more information to them than just a static poster. It can have digital feedback telling them what they're putting where and whether it's supposed to go in there and how they're doing as a building. And that can be motivating and incentivizing. We can also use smart waste planning to make sure that public waste bins are located close enough to people, and also use new technology that ensures that waste bins are serviced only when they need to be. So you save human resource effort and time and money, and that they can compact as well to keep them in use as long as possible. We can also make it so that people use the microcomputers they have on them to connect with waste more. So I'll talk a little bit about more about that in a little bit. And on the bottom right, you can see we're talking also about a local plastics recycling idea. It's called the Precious Plastic Project. It's something we're going to try to do at Concordia too. But you can essentially deal with recycling right in a local community by establishing some basic technology that cleans, sorts, and shreds up materials for 3D printing. Next slide. So this is what a reuse center might look like. And this is one of the main ideas that I proposed for the Lachine site. For a dense area, we could do something similar to what we've done at Concordia. Our center is called the Concordia University Center for Creative Reuse. You might have heard of it known as Sucker. So basically the idea is simple. It's a space where we collect unwanted materials and give it a moment to rest so that people can get inspired and use it in a creative way. And a creative way doesn't mean you have to be an artist to use it. It just means you use it in a way that it wasn't intended for originally. And what we've done is we've simply tracked all the materials that have come into and out of the space and asked people to estimate how much they would have spent on those materials. And we were able to estimate how much cost savings that a project like this brings to the community. So in a couple of years, we've saved Concordians over $200,000 in new purchases. And I think when you start tracking the utility of creative waste management like this, you can start to justify spending a little bit of money on labor, time, and even simple technologies like a space and people to operate it. So one of the people listening in is Arian. So if you have any questions, he might be able to field your questions, by the way. In our vision, we also imagine these collection bins in the residences, but even in the commercial establishments can be picked up by staff members at a reuse center. They can operate electric cargo bikes, and we could potentially even collect all that extra packaging waste that's being generated these days with a lot of Amazon shipments and take them right back to Amazon, who's going to be headquartered or have a location nearby. So next slide. Next slide, please. Thanks. Okay, another idea is, okay, well, I was gonna, if you go back one slide just for a minute. I think we went to, okay. So moving from a linear to circular economy is the core concept when we talk about reuse. And basically what happens a lot is we see people throwing away good materials because it's not worth enough to post for sale. And also it's not worth their time to try to find somebody to reuse it. So really the idea is to make life as easy as possible for these materials to be connected to people nearby who want them. And we can use mobile technology and artificial intelligence to recognize materials being disposed of and indicate to people nearby that these materials are available. So that's one of the other ideas that we could test out in Lachine is how can we activate materials more using technology like machine learning and cloud data to say, hey, there's a lot of good wood nearby or this kind of electronic waste nearby. Next slide. And so the idea is waste management needs to move to the Internet of Things. It needs to be AI powered and it needs to be smart and connected. And there's a lot of different ways we can connect it, from individuals to smart waste bins. Containers can track what's going in them. Reuse centers and even the eco center can track what's coming in. And all of this data is very valuable in a lot of other ways than just telling people what material is being thrown out where. We can also use it to assess how much of an environmental reduction in impact we have by all these waste management interventions, economic savings. We can potentially use it to generate tax or citizens can advocate for changes in packaging, like our Help Me Go Zero Waste campaign, where people actually post pictures of what they're throwing out and that they're frustrated that this item is not recyclable. That can help accelerate those kinds of interventions. Anyway, that's it for my slide. Go on to the next one.
Hi, everybody. My name is Jimmy Barco. I'm a PhD student. Okay, in order to get the zero landfill, not only in the Lachine area, into Montreal area, we were working in a specific technology with the objectives to include or to add a thermochemical process with the objective to get more energy from the waste. So actually we have a huge potential here in Montreal, 930,000 tons. So the objective is compare technology, thermochemical and biochemical. Actually, in Montreal, using anaerobic digestion and landfill like principal technology. So my work focusing in analyze other option, in this case thermochemical alternative. So I using the same capacity for the technology, and then compare the power generation, the really capacity to produce energy using this waste. So in the end, we have an answer to that question. Using thermochemical process, we have 80% the more capacity to use in better way the waste producing here in Montreal. Please, the next. Thank you. So the conclusion is the waste composition here in Montreal is 60% biodegradable and 31% non. Okay. So with this information, we can into the specific design, the equipment to use this technology, maybe centralized option, and use the mix or the municipality solid waste. So the models or the analysis, these options, we get a thermochemical process has a potential, the 0.79 megawatt hour per ton. So it's a good option to increase the flexibility and the real capacity to use the waste here in Montreal. Thank you.
Hello everyone, my name is Sofia, and now we're going to talk about wastewater management. And you always hear about zero waste and why not zero wastewater. So today you know, everyone knows 100% of wastewater is discharged into centralized wastewater treatment plants that we hopefully our vision for Lachine Eco-Quartier or Eco-District is 70% of local reuse and recovery, which means reducing greenhouse gas emissions and reduce local and contact sewage systems. Next. The current situation of wastewater management, what's the problems? First and foremost, wastewater treatment plants emission greenhouse gases about 33% of greenhouse gas emission by municipal activity in 2015. And wastewater collection, and if you consider the distance between Lachine and centralized wastewater treatment plant Jeanne-Marcotte is 30 kilometers, and normally wastewater collection and pumping consumes about 0.1 kilowatt hour per cubic meter. So for Lachine district, it ranges from 45 to 250 kilowatt hour in a day. And then drinking water treatments consume 10% of total, about 10% of total municipal energy consumption, which is not too much less. And the biggest problem is the plant only provides primary treatment of its sewage, that sometimes we have sewage dumps into river for stormwater conditions, and this is a kind of health risk. And what is the potential for the wastewater? Decentralized wastewater management with source separation, with separating black water and gray water collection, treatment and reuse will maximize wastewater resources like energy, nutrients, and water recovery. Next, please. So in residential wastewater generation, 70% is normally gray water and 25% is black water, which means toilet water and the water from kitchen things. And wastewater potential for Lachine district with residents of about 10,000 people means more than 2 million wastewater liter per day and more than 1.5 million liter gray water per day and more than 500,000 black water. Next, please. Well, what we propose for Lachine district for wastewater management is in all eco-districts, they use source separation sewage system, which means separating black water and gray water. We can use black water and kitchen waste, which means some food waste from coming out from the kitchen sinks for energy recovery. As you know, black water have some organic matters in it that can be used in anaerobic digester for biogas generation purposes, which can be used biogas in CHPs for producing electricity and heat. And we can use the digestate in compost rooms as well. But the other option is using a technology, which we're gonna talk about in next slides. It names wet-as. To treatment the black water, and using this treated water for irrigation or safe discharge or other purposes like car washing or something, and then is using the sludge in max. It's a kind of autogasifier for producing energy. And the other side, we have gray water, which means water coming from shower and baths, wash basin, and washing machines, that we can treat it in electrochemical treatments, and then we can reuse for toilet flushing and irrigation. And the other option is collecting the rainwater and groundwater for biological and UV treatment, and then also we can use it for toilet flushing and irrigation. Next, please. Well, as I said, we can generate energy from black water and kitchen waste in anaerobic digesters. Methane generation from literature range is about something 8 to 13 cubic meter methane per capita in a year. And if we assume methane generation about 10.5 cubic meter methane per capita in a day, we're gonna have energy potential of about 104 kilowatt hour per capita in a year, which is mean 1,040 megawatt in a year. And next. Well, in current situation in Montreal wastewater treatment plant, they use sludge incineration, which means more fossil fuels, and it's consume more energy than it can produce. And also it means more greenhouse gas emissions. But what we propose, the sludge digestion, is generate more energy than what it consumes. But also, both of these have some weaknesses. For example, incineration, as I said, consumes more fossil fuels, which means carbon footprints, greenhouse gas emissions. The ash is not green, and it has some other odor from sludge handling and higher operation costs. On the other hand, for anaerobic digester, it needs expert maintenance, capital cost operation skills, and we have digested disposal as well. Thank you. And next.
Good afternoon, everyone. In this part of wastewater group, I'm going to propose new technologies that exist in Montreal. As Sophia said, if we consider different infrastructure for piping system in buildings to separate gray water from black water, we can use these facilities. For instance, wet-G is used for treating gray water and wet-S is used for treating black water. If we treat gray water, we can use it again in buildings for toilet flushing, irrigation, or car washing, and etc. And if we treat black water, we can use it for irrigation and safe discharge to the environment. The technology of these two facilities is electrochemical treatment technologies. And we do some calculations for sample buildings. For instance, we consider a 6-floor buildings, and in each floor we consider 8 units with 3 residents. So we have around 144 residents. As you can see from the table, these residents generate total wastewater around these numbers, gray water and black water. And also, so all in all, we can use 1 wet-S for 6-floor buildings and 3 wet-G for treating gray water. Next slide, please. Okay, as Sophia said, when we treat black water, we generate a sludge as well. With these facilities, MAGS, macro auto gasification systems, we can treat the mixed waste, sludge, food waste, and etc., and generate hot water from it. MAGS can treat 50 kilogram of mixed solid waste per hour, and also produce 120 kilowatt of hot water at 60 centigrade per hour. As I said, for 6-story buildings, if we want to use MAGS, we can only use 4 hours of operation max, and it can work 24 hours. So for number of 6-story buildings, only we need 1 max. So we wanted to consider a centralized room for collecting all waste of buildings and their sludge to convey to the 1 max and use it to generate hot water. I want to mention that this hot water couldn't be used as a hot water in buildings because some legislation, but we can use it to meet the heat demanding of buildings. But 60 centigrade hot water is not enough for heating buildings, so we need a boiler or preheater to increase the temperature for using in buildings. Next slide, please. The overall beneficial of reuse and reclaim water from wastewater could be categorized as low economical, energy saving, and environmental benefits. For instance, if we reuse or reclaim water from wastewater, we can decrease the energy consumption and money for treating fresh water as a potable water or collecting wastewater. Also, we can reduce the potable water consumption by around 70% and also send zero waste to landfill. Then also, as I said, we can decrease the energy demand for heating of buildings via hot water. And I think that the most important point is environmental benefits, because we want to preserve our environment. So the reduction in greenhouse gas emission by 50% or less contamination discharged into the environment is really important. For instance, if we use these facilities, we can treat our sewage, and if I don't want to use it or reuse it, the one point is that we can discharge it to the environment without any contamination. Next, please. Faisal, it's your turn.
Yep. So, thanks, Nargis. So in conclusion, what we're recommending for Lachine is a mix of smart waste sorting, because you have to start by collecting things the right way, in the bin designs, the locations, and how we educate the community and involve the community. There's a lot of opportunities there. Reuse, we need to prioritize reuse of both material waste and water waste. And we need to take advantage of the opportunities for recovering energy from waste too. That's something we don't do enough for both materials and water waste. So gasification technology that Nargis was talking about, and Sophia, that's something that we could try out. Anyway, thanks everybody. If you have any questions, let us know.
All right. Thanks a lot to Group 3 and the whole waste team. Are there any questions? But one group to go, so it's the end is near.
Yes, hello, Ursula.
Hi.
Alfred speaking. Hi. Congratulations to this great presentations. Let me allow to put one question to the last group, to Sophia. I just would like to point out that if you go to such decentralized solutions, you have to take in mind that the final effluent discharge has to be controlled and you have to make sure that quality for discharge of final effluent and for reuse is controlled. And to do that, you have to make sure that carbon, nitrogen, phosphorus removal is done to the limits required to protect the environment. And second remark is that think about if you have such small units in operation, they have to be operated 365 days per year. And if you want to make the efficiency sure, you have to make sure that these systems work 24 hours a day and 365 days a year. And this is an important fact. What I want to make sure that if you study in this extremely decentralized concepts, that the systems can be operated in this way, which I pointed out. But thank you, it's a very interesting study, and it would be great to have the overall energy balances compared to more decentralized systems, centralized systems will enable up to 100% reuse of treated effluent. Thank you again, and thank you for letting me participate at your presentations. Thanks a lot.
Sophia, do you want to comment on this? No?
Dr. Ursula?
Sorry, I'm muted. I'm sorry. Thank you all for all your nice comments, and it was very interesting to work on all of these. And I want just to say we should consider, as you said, all of these options. But here I just want to talk about how an aerobic digester can make difference for what it is the incineration now is used. And for digestate and using the centralized wastewater treatment plants, there is so much efforts and maintenance skills should be done and for implementing, and thank you.
Yes, Thank you.
Yeah, we for sure will follow up on this. And as I said, the goal is really to write a paper on this and comparing exactly the technologies and be sure of all the numbers. So thanks for your comment and for your input to the course.
I have a question also, if I may. This is Dominic Frigon.
Yes, sure.
So I may have missed it, but you're proposing a zero waste treatment based on gasification, correct? Or that's what you're favoring?
It's not. It couldn't be zero. Which means we gonna be a kind of reuse and recycling system, and we can then burn the sludge in gasification system. It's a kind of reduction of wastewater amount, and it's a kind of saving, and just we name it zero wastewater to compare it with the zero waste, which means not it's exactly not mean zero waste. Okay.
So I guess what I wasn't sure is what was the end product of the either the gasified residues or maybe the anaerobic digestion residues. What were the end of life there? Were you hoping to apply it to agricultural land or something like this, or what were the
Actually, as I said, there's a problem with the digested of anaerobic digester because it's come from black water. There's some, legal bans that they don't allow us for using in agricultural purposes. But the biochar coming from the gasifier, it's completely different, and it can be used, I think, in the agriculture purposes.
So here's my question then, and So you're using an electrocoagulant, right? The technology there. So that means that you're going to increase to some degree the level of heavy metals in your biochar. Could that be a problem?
It's a problem.
Yeah, it is a problem. I know.
Okay. Something to think about.
Yeah. Yeah, thank you.
I think that's just the beginning of the work. And thanks also, Dominic, for your input to the group. No, we need to follow. I mean, we didn't have that much time to work out, sort of completely work out.
I don't know. And these systems are very complex, and Alfred's point were certainly well taken, but these systems are very well complex.
Yeah.
Ursula, it's Maya. I have to say, I have to leave soon. So I just wanted to say goodbye. I will miss the last group, and I would like to have all the presentations, and I'm really impressed. I'm really happy to have all the numbers and the calculations. I can't say I understood everything. It's a bit, some of the stuff is a bit beyond me, but it's very good to have it all, and we will integrate it into our work. So I thank you very much for the data that we did not have.
Yeah, that's the purpose of engineers.
Yeah. So thank you for the numbers. Thank you very much.
Okay, thank you for joining. Okay, let's start group 4 that they still have some audience left. Milad, please. Thanks, Maya, for joining.
Bye.
Okay. All right, so I'm going to go over the group 4's focus in the presentation at the moment. So as you can see, group 4 is focused on transportation and green spaces, specifically on the Lachine-Est area, on the next priority, the whole Lachine, and then further away. But then we were focused on Lachine-Est just like every other group. So the main question that comes to the group transportation in the beginning is that what is the aim and what should be pursued for this work? So you want to actually, so let's shift every thinking back to transportation, away from everything else that was discussed, and see how transportation sees this whole development and basically redevelopment of that area in order so that the transportation side is satisfied. But then when we say it's satisfied, it means there got to be some metrics or some sort of measures that says that how much that satisfaction is happening on the transportation side. And the question was basically in the beginning that what that main goal is. So like everybody else said in the other groups, there's things that are going to be pursued. Some goals, some things that are pretty high to reach, but it's good to aim for them, and that's where our group is also aimed for. Basically, to some of these things that are equity, access, and efficiency of the environment, and those kind of like green spaces, the zero energy, and then the question comes how to see these things from the transportation side. Now, the transportation side is if somebody can go deeper into it, it will basically be consisting of the roads. Basically, mostly it's the roads and streets and connections between the different locations in the city is basically what the transportation stands for. And when you think about the roads and network of the of movements in the city, automatically the geospatial data comes into question. So meaning that we have to explore data that is geospatial, and we have to see how that data plays out in different scenarios of transportation. So one of the things that transportation is worried about or concerned about is mobility issue. So the mobility is one of the things that you want mobility to be as smooth and as efficient as possible in a scenario in your urban area, meaning that you want your people to go to work and come back home as fast as possible, the least congestion of traffic, least amount of emission produced by that, least cost, hopefully, and overall also satisfaction from the people, because you don't want to just maybe you create a public transport, but you cram people into one small area, and yes, you get the job done, but they're not satisfied. So it's a constellation of different factors that play into that kind of a setting. Another situation with the transportation is access. Through the network of the streets and roads, you get access for facilities, and this is important also. So it's not always how the cars go around and how much the congestion and traffic is. Also, how good I can go to a certain location and get service from that location. So facility access and mobility, I would say that these two are the main goals or main focuses of the transportation in order to improve and build upon this stuff. Now when we come to those two parts, there are different challenges that are being faced for each of them. For example, in the mobility area, we have many challenges, especially in the newly emerging countries, countries that are right now coming to be more advanced and more developed. They are actually facing these problems more than anybody else. Things like multiple issues, like a congestion or high traffic in those areas, high amount of air pollution, a large amount of accidents. For example, in some cities in different parts of the U.S., you have this Vision Zero actually initiative that is being pursued, meaning that they want actually to not leave anything unseen in the city. Basically, everything to have that kind of so we have zero energy, we have zero a lot of things. We have something else called zero vision or Vision Zero. And that Vision Zero is basically aiming for that, to reducing the traffic and accidents in the city as much as possible. Another problem is the trucks that are going to be in the city and going around, and they have to deliver the goods to the people. And so some thinking needs to be done on that side too, because the more trucks come, because people are tend to get into the online shopping habit more and more. And this is going to create more traffic for the trucks and delivery of these things. And that's going to be a future challenge, I would say, for even advanced countries. Another thing is that how to think about this logistics of these trucks, or how to think about the logistics of this thing. So I would say even the mobility part could be broken down into two pieces. The mobility of people and mobility of goods. Mobility of people, meaning that how people go around the city, how they go to work, how they actually pedestrians, how they go around and shop in their own neighborhood. And then mobility of goods, which could be the freights or like people who move things by train or move things by trucks. And these are also some invisible things that are going on in our city. We don't see them most of the time, but they are actually, they have a big footprint in terms of emission and those effects that they have. The other area that we focused on was basically the access, just like I said. The access is important because you want to know where you have better facility access and where you are lacking that access, and you want to improve that, because that's, at the end of the day, that's something that's going to stay there for the resident or the citizens, and it's going to affect a lot of things, meaning that people over there are going to be moving out or in depending on the situation of the facility access. The price of the real estate could change dramatically because of the facility access. A train station could change price of the nearby buildings a lot, like unbelievable in the big cities. So these are the things that's also important. So it's not always the roads and streets and how big the roads and the streets could be, because if you don't have access to nearby facilities, there's no point really for it. So now we have some challenges in access part also. The green spaces, we want access for people to go to park in green spaces. The cycle or walking paths should be already put into the infrastructure. So that's something that already is being paid a lot of attention in the big cities. But like I said, the countries that are developing, their big cities are still lagging behind on this part. Bike sharing facilities is something that you can see that in large cities in US and Canada or Europe, it's being laid out slowly, but surely. So you can see that big cities, one of them that in Montreal is expanding as we speak. Public rail transit is important. In this Lachine area, we don't have that much public rail transit, but then it's very important to have that also. Hopefully, the new tram line that they're proposing that can kind of fix that issue for this area. But overall, public rail transit is a luxury. You don't find that in many cities. So it's just some cities have it, and that's some part of the city, and things gets really expensive over there. Everything basically around them. Commercial facilities, something people usually lose sight of. If you actually pay attention, some of the ads that people put for their property to be rented or be sold, they usually mention our place is close to nearby, let's say, pharmacy, close to nearby this. So that's like a positive thing. It's a very positive thing that they actually mention anything. And that means that our property is worth more than you think. So you can see that being close to commercial facilities is also a big positive thing. And then when you do these things, the high car ownership bring down the high car ownership, because the high car ownership would mean that that's basically people's reaction to the situation. So when they don't have enough access or close access to the facilities, when they don't have close access to the public transit, then they would be forced to go towards the car ownership, and that's going to be creating congestion and emission, two bad things that you don't want to see. So focusing on that part is also going to reduce that. So question is that how to actually approach this thing. As I said, we need metrics. We don't want to just talk about things and qualitatively mostly talking about things, and maybe on theory you could say a lot of things about many things, but when it comes to quantitatively finding out what is what, that is going to be there's going to be few options or few routes to take. For example, for the access to facility part, we have opted for TOD metrics. So TOD stands for Transit Oriented Development Metrics. Meaning that when you have an urban area, when you have an urban setup, then using that urban setup, what kind of metrics of access do I have? And that's when TOD comes in. And then you change the scenario of the setup, you change your urban design, and the TOD metrics change. And that tells you how good that urban design is fitting with the surrounding network of the roads or the facilities. And when you go and look into this TOD metrics, you see that they're mostly qualitatively talking. At some point, they bring it down to some factors or points to be given to different things, and scores to be given to different things. Three sub-metrics, basically. There's a lot of metrics in this TOD, and I don't want to go into details of what the whole TOD is, because this is not the point of this session. But then there's three metrics that we are going to be focused on. The walk session, meaning the walk score of the TOD, which is going to evaluate how good your urban design is in terms of walking for the people. The cycle score is going to be looking into how good it is in terms of the bikers, people who want to bike around. And the transit also is going to look into the transit part. Now in this Lachine area, we don't have rail transit for the the STM rail transit, so we have the bus stop, so we focused on that one. We also brought in the tram scenario, and that's basically the bulk of the transit score for this. When it comes to data sources, it was really hard because every one of these metrics is going to require you to get your data from somewhere. They're not actually, it's not all at one place sitting for you to just pick it up. You need to put into together like pieces, like a puzzle pieces together until you reach to something. For example, in the walk score, we're looking to walk to school, walk to convenience stores, meaning the small stores, walk to supermarkets, grocery store or malls, and pedestrian comfort, meaning that how much shadow or sunlight is in a certain area. In the cycle score, we're looking at the access to Bixi stations and to cycle path, because that's what, if you were a biker, you would prefer to be close to those two. And then the transit score is the distance to the bus. For each of these things, we've collected data sets from different sources. So for example, there's 3 sources that I'm mentioning here: LiDAR, MTL Open Data, Montreal Open Data, and census tracks. Census data is also very valuable. On the other hand, one of our members of the team, he has also gone deeper into the mobility of goods. So this is the part that I just talked about. It was the access. So there's another part that's mobility of goods that's just basically under the mobility part. Like I said, mobility of goods and mobility of people. Mobility of people is not covered by us. That would require much more work and much more scope. But then mobility of goods, one of our members, Reiner, he has worked on this, and he has collected some data sets from around with the same data sources I just mentioned. And he has created this GIS data road network for the Lachine-Est area, and estimated some numbers around the area in terms of population and in terms of the service area that this population could get, and created 2 scenarios. So I'm going to leave this for him to come along and maybe give more explanation for this part. He would be explaining it much better than me. So I'll leave this slide for him because he's going to be coming back to this one. So back to the access metrics. So the access metrics, like I said, we need different type of data sets to be collected. In this slide, you see that different plots have been shown to you. On the top left corner, you can see that that's a cycle path and street network of the Lachine-Est area. On the top middle is just the current green spaces in the area that is being shown to you. This was coming from the LiDAR data. It's a point cloud data that is being collected by the airplane. So LiDAR data provided that for us. On the top right corner, you can see that there are the buildings, the current buildings, setup of the buildings in the area. And that one also came from the LiDAR data. So that's point cloud data from the laser scanning. On the bottom left, that's a footprint data, footprint of each building, and that one has been created by Microsoft. Microsoft has made that open source in public. On the bottom middle, you can see that different facilities in the road. So the bus stations, you see majority of facilities in the area of Lachine-Est is actually bus stations. So no other facilities like stores or schools or this kind of things. So the other facilities are further away from the Lachine-Est to the left side. And also the current building. So these are the 3D model of this building currently at this point. The tool that we used for this work was QGIS. So QGIS is a GIS software, geospatial information. And that basically helped us a lot in terms of handling the data and going around with data and doing these things that you can see here. So this was actually good to give you an idea of what the current scenario in the Lachine area is. And then we're going to go through and calculate those metrics. And then at the end, we're going to look to see, compared to a future scenario, the current scenario and future scenario, how those metrics is going to change, the TOD metrics, transportation oriented design metrics. So how those things are going to change, we're going to compare that. Here's I would say, different satellite images I collected from different times for the Lachine-Est area, and you can see it in the form of an animation, GIF animation. that how this area has been just industrial this whole time, and it has not actually been, there has been some changes around depending on the year of it, but not just to have it basically gives us a better view of what is the short-term history of this location. This location has been made basically for the last 5 years as it is, give or take. Some buildings or construction, I could see that, but not much. So this is the situation with the current scenario that we're working with. Also, in terms of how the metrics are good, so we calculated the metrics for the whole Lachine area, for the whole Lachine district. And then we wanted to see if really, because we wanted to work on Lachine-Est anyway, but we were curious to see how this is going to compare to the other locations in the Lachine district, how the Lachine-Est is compared to those. And if you actually look at here, this is a total. What you can see here is a total score of how good a TOD or transportation rotation design metric is for the whole Lachine district and on each building. So this is a building by building. So for every building you have a color from the color map, and 100 would be the best score. So the 100 is relatively the best throughout the Lachine area, and the 0 would be the worst. So as you can see, that makes sense. The 0 is all the way over there. And you can see that although the Lachine-Est area is supposed to be in this bottom right corner, and it's like overall this bottom right corner is supposed to be glowing and having a better access or better metrics, but actually Lachine-Est is kind of isolated in that area. And I've actually shown in the blue circles and ellipses that how this lack of service in those areas been highlighted. So those blue circles are showing you the locations with low service level, and then the red ones are showing you the high service areas. And I would say the cool part of it is that how Lachine-Est is next to a high served area, and yet it's still, and it was before, not paid attention to that much. This is our future scenario. So now, thinking about the current scenario, you see that how the whole area hasn't been changed for a while. It has almost no service facilities in the Lachine-Est area. Anybody in the Lachine-Est area, if any residential unit is going to be, has to go outside of the Lachine-Est area to get anything. The only thing here is the bus stops. But then the question is that what is the future scenario? The future scenario is basically here something that the different groups have been creating it. One of the groups has created this scenario on the bottom that I show you. On the bottom left corner is a 3D model of this scenario, and the bottom middle is basically the 2Ds of this scenario. And this scenario is only being laid out on the Dominion Bridge area. It's not the whole Lachine-Est, so it's just the Dominion Bridge area. And it's just, I would say, good idea to just look at to see how a development in this area can affect overall region. So how this Dominion Bridge development is an imaginary thing. So right now this is a future scenario. We're just comparing it to the current, and we're not trying to get a complete reality thing out of the development. But then the pipeline is there. So the main thing is that if this location gets developed this way that we are presenting it, how would that change the metrics in the surrounding area of it? Another thing is the tramway. So basically, this tramway is also part of the future scenario that we have considered here. So this tramway is something that we got it from the GRAM, and is a tramway going from downtown to Dorwal, and it's going to connect the Lachine and East and Lachine on the way going there. And this tramway has been talked about it to see if it actually gets to fruition. But then at this point, we just consider it as a future scenario, assuming that in future this is going to be there too. So what else the future scenario has from our side? We also planted some trees, right? So you could have buildings but not trees. That doesn't work. So we planted some trees here, and the trees are artificial. So we just create the trees and then we model them. And we basically give them random models of canopy for the trees to be able to later on get shadow analysis from them. So now this is, now that I explained the current and future scenario, it's not a bad idea to actually look at them on top of each other, overlaid on top of each other, to see exactly how they compare to each other first in terms of data. This is not the result yet, so this is just the data. So here you can see that on the left side, here is basically the new trees that has been planted. So this is part of the new design or new future scenario. So we have planted different trees on the way around the buildings. On the right hand side, right top, you can see that the trees and the new building is being shown. So the old building has been taken away, and the new building has been going into place. And different trees around the building and the basically tree lines on the streets and stuff. On the bottom, you only see isolated, the building isolated. So that's a plan. If you look at it from above, so that would be the plan. This is right now showing you a depth map, meaning that from above, how far the building is. So the taller the building, the darker it appears. And then the more less elevation it has, the lighter it appears. Another metric, part of the metrics that we have calculated over there is shadow analysis. So we wanted to actually see how it would perform in terms of shadow. And here is a scenario of how would this be without the trees. So the trees hasn't been considered in this one. But then you can see that this new building, if you actually put that new building in here, you get around the day, from the morning to the evening, you get this time lapse of different shadows in this area. And this is important because we want to measure the comfort of the pedestrians in the area. And sometimes, depending on where the country is. So if you are in a hot country, your comfort would be coolness or shadow. If you are in a cold country, your comfort might be the sun. Actually, you want to get the more sun. So this can be interpreted in many different ways. I would assume that for Quebec is basically the sun is desired more than the shadow. But you see that there are some locations in even the cold cities that high-rise buildings create this kind of like a constant shadows or year-round shadows in the valleys and the streets that actually feel like very dark and very I would say less towards the green part of the thing. So if you think of what green should look like, that's not exactly opposite of that. Here you can see on the left-hand side, on the right-hand side, you can see on top that's the same shadow that we're showing here, the time lapse, but overlapped on top of each other. So basically, that's an integrated shadow over the whole area, and the trees also are included. You can see actually next to it that trees are appearing on it. On the bottom, it's the same thing, but happening in summer. So even the winter and summer is different for the shadow and the length of them and the whole thing. So because you can see in the summer, you have smoother shadows, shadow boundaries, but in the winter you have sharper because the shadows are more slanted and less lived, basically. They're gonna take less time. So here are the scores that have been calculated for these two scenarios. There's the current scenario and the future scenario. On the left-hand side, let me get rid of this. On the right hand, on the left-hand side, left bottom, you can see the current scenario, the metrics of the current scenario. The blue boundary is actually the Lachine-Est. The green boundary is Dominion Bridge. And the whole area is Lachine-Est, including whatever from Lachine district that is in the vicinity or neighborhood of it. So as much as it can impact it. So in the current scenario, you can see that this is the situation. So you have score for every building, and you can see that the glowing part of this current scenario is actually on the left hand side of the Dominion Bridge, and that part we already signed the whole Lachine district that it is actually glowing, and it is actually highly served area. And on the right hand side of the Lachine-Est or Dominion Bridge, there is like lack of service or lack of the glowing part that you can see. But then when we implement the future scenario, you can see that with that future scenario and implementing some commercial units in that development area, you can see that quickly it actually impacts the whole area. So this development is going to actually make the area around it to be smoothly actually distributed. So now you can see that actually the most important part is not how more it is. You can see that the values went up to 97 compared to the 78, but then that's actually not the point. The point is that it actually lowered the inequality in the distribution of it. So you can see that now it's actually more smoothly distributed than before. The north part was actually completely far behind the lower part or the south of the scene that we see. And also here I'm showing the changes between these two. So the changes show that how much change happened. We've excluded the development itself because the development itself is creating the change. So the development itself is not there, but then the changes that has created by this development, you can see that it's a uniform change around the development. And that's the important part. So all of these houses around this development are gonna go up in prices and be ready for that. So the current versus future scenario in terms of how better it become. So right now we can see it visually, but then how better it becomes. So if we actually overlay these two together and get a scatter plot of both of them, we can see that the values are about 1.3 higher compared to the current scenario. So future scenario made 1.3 than current scenario. And this is including all the things, all the houses in the neighborhood, not just the development itself. So this development would have a 30% increase in their TOD score meaning the transit or in the development, or how good this development is for the transit or vice versa. So basically increases 30% in that sense. So from here, that was basically the access part that I explained to you guys, and then I showed you the result. Here, I'm gonna pass it to Rainer, and Rainer is gonna go through the mobility part for you guys in 2-3 slides, so it shouldn't be that long. Go ahead, Rainer.
Hi, Mila, thank you. But first, I think, could you please go back to slide number 5? Yeah, this one. Okay, as Milad explained, there are 2 parts. First, the accessibility to the network, and the second part is the mobility of people and of goods. And during this summer course, we had the chance to discuss with local stakeholders, companies, and there was topic it popped up, and it was the mobility of goods, and especially the concept of this mini hubs and this last mile transportation. And we decided to analyze, okay, how does it look if we would like to build a mini hub located in Lachine-Est? And therefore, we went through all the numbers, and we got from Jalon and his concept, or the concept they implemented now in Montreal. It was that the first mile, or the first distance is done by trucks, and only the last 1 to 5 kilometers is done by e-cargo bikes. So, and therefore we decided, okay, we looked at the data, and the Lachine-Est area, it's less than 5 kilometers. And we said, okay, imagine if we place a mini hub in Lachine-Est, what would be the service area? And on this figure, this green area is a 5 kilometer radius. If you place a mini hub in Lachine-Est, this would be the service area. Based on this area, we calculated the amount of people living in the service area, and added also the expected people for Lachine-Est, and we ended up in around 25 to 27,000 people. And then we created 2 scenarios. One scenario was business as usual. That means trucks pick up. Can you go to the next slide, please? To explain a bit better the mini hub concept. Yeah, the first scenario is trucks pick up their parcels in the bigger warehouses, which are normally located outside an urban area. They drive 15 to 20 kilometers and deliver the parcels. And the second scenario was for us, place this mini hub in Lachine-Est. And the first miles are delivered as usual by trucks, and last miles by e-cargo bikes. And now if you go to the results number, to the slides. Next. Okay. No, previous. We had to take some assumptions. And what assumptions did we take? We did an analysis on how big capacity of a normal truck is, and we found some studies. And in average, a truck has a capacity of 400 parcels. If you compare this to e-cargo bikes are smaller, but you have to deliver the same volume of parcels goods to the endpoint. That means you need more e-cargo bikes, and one e-cargo bike has a capacity of around 40 parcels. Taking this number and analyzing how many parcels per year and person are ordered in general for Canada, and comparing this with the population size, we ended up with the total parcel numbers per year and per day of 567,000 and 1,500 parcels delivered per day to our service area. And our next question was, okay, what does that mean? We know now the load of parcels, we know how many trucks will enter in this area. And if you can go now to the next slide. We wanted to see what does that mean in respect of CO2 emissions, and also in savings, and how much less trucks we will have in this service area. For scenario one, business as usual, big warehouse and delivering to the end customers with trucks. We have a total load of 3.8 trucks per day, and a distance they have to drive of 77 kilometers per day. We also took into account the CO2 emissions of trucks in grams per kilometer. And then went to scenario two, substituted the last 5 kilometers with e-cargo bikes. And for the e-cargo bikes, we made an assumption that the electricity for charging the battery is provided by local wind turbines or PV, or maybe hydropower. And therefore the e-cargo bikes will not have any emissions. Comparing these two scenarios, in scenario one, we have in total 6.6 tons of CO2 emissions per year. And for scenario two, nearly 5 tons per year, which means nearly 25% of savings in CO2 emissions. But the more important part is if we compare how many trucks will enter less in this area, we ended up with a number of 1,417 less trucks entering the service area. This looks at the one hand good, but at the same time, we should also see what does that mean in increase of e-cargo bikes. Maybe there could be also in negative effect, but from the point of view of CO2 savings and less big vehicles in an area, this last mile delivery with mini hub concept makes sense in our point of view to go more into detail. And if you go now to the last slide, this is our conclusion. Maybe Milad, you make the conclusion for the accessibility part, and I.
Yeah. So, thank you, Rainer. So basically, then the question. Yeah, that was great. Basically, we have, just to give another, again, because it's always important in any situation to know the big picture. The big picture, you lose the big picture, you lost everything. The big picture here is that we have a transportation, we have a mobility. The mobility part was only covered by Rainer on the mobility of goods. There's still mobility of people who are not being covered, and we don't claim that we have covered that. So that's part of it, that is this business that it would need to be done. There's just so much to be done. It's just pretty much a drop in the ocean right now. And then also on the other side, the access part, the access we measure the access for different facilities, and we compare two scenarios together, and we concluded that there's 30% increase of access because of this development if it happens in the Minion Bridge. Now there's even more developments are supposed to be happening in different parts of Lachine-Est, and that would just make that whole area going up in value. So so that is basically the scope of our work. But then what we didn't cover, mainly, I would say the main part that we didn't cover is mobility of people, how people's cars and how people's foot traffic happens, and how that's gonna affect everything. And for that, the reason we did not cover this was because it would require much more complexity, and it would require much more sophisticated tools. For example, I'm just here right now showing you two tools that are being widely used, open source tools, that are being widely used for this kind of application. And in future, I would say that this would be the route that we would take, and we would actually have these simulation engines that would simulate any scenarios for us in terms of mobility of people. Now, the mobility of goods also could be inside here. Here, there's one of them called MatSim, which is actually a larger scale simulation engine that you could have at the whole city to be simulated. But then we have also another one which is called Sumo, which you can go down to pedestrians and smaller scale. So that would be something very useful for Lachine area or Lachine-Est area if one wants to do that. But then basically the horizon is still open, and we're excited to actually be able to continue this on this path. Overall, there's just many conclusions you could make, but I think that the best is that we keep the future steps or future scope open, and including more things that we didn't cover. Yes, we covered the walk, cycle, transit, and everybody knows that probably walking and cycling and things need more infrastructure. We need more bike paths. We need more access to facilities and this and this and this. But then there's so many scenarios that people can come up, and everyone has a different price or has a different cost. And it's important to know which one is better than the other one. So I would say to get to that point, we would definitely need to go to this direction, much more focus in the part of the mobility of people also. So with that being said, I think we're good at the moment. Any questions? Any comments, critiques?
I don't know. Did Rainer want to say a conclusion?
Yeah, I can say, okay, my conclusion for the mobility part, as you know, I sometimes see also different, yeah, I see some topics also from the business side. When I went to all these publications and analyzed these concepts, we heard a lot of about open data, about how we can share data, and I think what is important, especially for this mobility of goods, I'm saying now, it's important somehow to think on how we can collect this data to create some tools on routing and to come up with routing concepts, and not to see it as a silo, more to see these things on a city scale, because I think then we can save costs, emissions on the city scale. And one other thing we didn't analyze was this whole life cycle analysis. Our focus was at the moment, during the operation, but especially if we talk, let's stay on this mini hub concept. We need 10 e-cargo bikes compared to one truck. What does that mean in life cycle? There is different lifetime, and this is also something we should focus on. And the last point is, I think if we really want to implement new concepts, we should start to think really in the early stage on the new business models and how they are going to change. My impression was there is a shift between this normal business to customer concept. There comes a new player into the market, and it's getting like you can compare it to an energy system. It's more distributed, and how you are going to manage all these things. Or maybe in the end, there will be some big logistic companies which are interested in to do this micro-organization things. But I think they are not really willing to do this. This is my impression. But at the same time, they are also not willing to give some costs or to pay some money the local players.
All right.
This was the final word, and I think we have finished with everything.
Thank you very much, Group 4 and all the groups for presenting. I mean, we are nearly at 5 o'clock. I was expecting this actually, that we probably need 3 hours, although every group was originally instructed to only spend 15 minutes. But as you've seen, there's been so much material in there. I think we needed the time for the presentation. So are there any questions or discussions for Group 4? No, it doesn't look like it.
Yes.
Yes.
Ursula,
okay, perfect.
If you allow me a small comment, thank you for the Group 4, for Millard and Rainer, for this great presentation. It was very interesting. What I want to comment, or what I would like to point out, is that it was very interesting because you showed, by implementing your ideas and your concept, at least a lot of trees, a lot of really green infrastructure which could be integrated within the internal city. And this is just a remark to maybe to Group 1, that you could, or you should integrate these ideas more to the architectural design and development of the district. Because without having a clear idea about the future mobility and transportation, and I think not only for the last mile, I would say it is a definite objective to have a final or a good solution about the mobility inside the district. And this, having done this, then we should start designing the buildings, designing the quantity of grid infrastructure, designing the energy, renewable energy sources, and designing, of course, the water consumption. So thank you for this, showing these opportunities which optimized mobility concepts allow to improve green and really green infrastructure within the city. Thank you.
Yeah, thank you for your question and being here. I would say that that is completely correct, that we need a mobility infrastructure in place in order to be able to evaluate a lot of things, including the architecture, the design of the urban area, and many other things. but it's kind of it's like a chicken and egg scenario that you have. Yeah, that exactly. So basically, one of the things that is going to highly influence the amount of mobility or congestion that you have is the demand and the supply of trips. So the demand and the supply of trips would actually be highly affected by the texture and the morphology of the people who live there. So basically, the distribution or the way what kind of people live in that area is going to determine how much mobility comes in and how much mobility goes out. Basically, the demand and the supply. And then you have that. Then you go and change. And this is the way I'm thinking about it. Is like more like an iterative way. So you actually evaluate the transportation part, and then you evaluate the urban design part, and then you tweak something here, and then you see the result over there, and then you tweak something here. It's just like a back and forth sort of a thing that go together at the same time.
Yeah, and that's what we're going to do in the next months, I would say, to bring this together and consolidate the data and publish it. So whoever has, yeah.
Okay. First of all, I think you guys rock. You did an amazing, awesome job. I just wanted to say, as far as mobility and build team number one, it's part of actually zoning process. So when you are going to do your massing plan for your zoning process, you actually have to show the mobility as well as your sun studies. So it is something that we have to always integrate, is the flow of people, where the roads are going to be, how the bike paths. It's actually part of today's zoning. It's not even like a different kind of a zoning. So I think it's cool to have those groups go together. However, we worked on this for 3 weeks, and I think that you guys got really far. I think it's just a good reflection to you to know that actually all the teams, you have a lot in common. Like there's a lot of things that will overflow. But I think as a beginning start, I'm extraordinarily impressed. And I think it's a really exciting thing to be able to bring like real life projects together with studies and best practices. So congratulations to all of you. Just want to say that.
Thank you very much. That was a perfect final word for this session, because we should close at 5 o'clock. I'm told, and that's about 2 minutes from now. So we're going to continue that discussion also in forms of public Zoom meetings, webinars. So everybody who's interested to continue can just contact Michael Bossert, myself, to put you on a list of interested persons for the work we are doing. So that was just the beginning, as Maya also said. And thank you all for participating, and thank you obviously all the students for the amazing work, and Michael and Ivona, who in the background have helped tremendously of organizing the whole summer course. So it worked well, it went smoothly. We had to do it on Zoom, but we met at least once, and we're going to meet tonight for some beer at Natalie's Terrace. So everybody in Montreal can look forward to a real meeting outdoors in sunny conditions.
You just pointed out that Rainer is not gonna come.
Yeah, completely safe outdoor environment, 6 meters from each other.
Thank you, Natalie.
Thanks again, and we see, I mean, everybody around in Montreal, we see you at 6:30.
Thanks, everybody. If I can just say a couple of words on behalf of Fourth Space, I would like to thank all the students for your presentations. Really incredible work. Thank you to Dr. Eicker, as well as Michael and Ivana Bossert, for inviting us to take part in your course finale. We are really in the business of making the research and academic activities at Concordia public, and therefore we appreciate your willingness to help us to create sort of accessibility and community around this